Let's go to the next problem. The next problem is not a confidence interval problem. It's a minimum sample size, and we have minimum sample size for a mean. I'm only going to do one of these as it pertains to a mean. Basically, it's always the same thing, except if we are given a population standard deviation, we would use that. If we're given a sample standard deviation, we would use that one. But no matter what, we have to use the norm.s.inv function to do this, and not the t-distribution, because the t-distribution requires that we have a number of things already, which we don't have, and that's what we're looking for. So here's the problem. Assuming that the population standard deviation for Florida annual teachers' salaries is 1,964, determine the minimum sample size needed to be within $750 of the true population mean of Florida's teachers' salaries. We know that E is equal to Z sub alpha over 2 times sigma over the square root of n, or S over the square root of n. If we reverse engineer this formula, and I'm not going to go through all the algebra, we get n equals sigma times Z sub alpha over 2 all over E, and then we square that. If we happen to be given a sample standard deviation, it's pretty much the exact same thing. We just substitute this S here for where we had a sigma. Again, we have to use the standard normal for minimum sample size no matter what. And if we're not given a standard deviation at all, then what we will be given is something where you'd have to use another way to approximate a standard deviation, such as the range rule of thumb. So let's see what we have here. N, that's what we're looking for in this problem. E is 750. Y, remember the whole keyword thing. The keyword is to be within $750 of the mean salary of Florida teachers. So that within basically means that that's what my E is. We happen to be given a population standard deviation of 1,964, but even if we were given a sample standard deviation, we would do the problem the exact same way. Or if we weren't given either, then we would have to do it another way, and I can tell you that that other way will likely be by using the range rule of thumb. My level of confidence is 95% or 0.95. Why? Because it's not in the problem, so we use the default. Which means my alpha is 0.05, alpha over 2 is 0.025, which we will need for this problem because we're not using the t-distribution for this one. We're using the standard normal or z distribution. And I can tell you that z sub alpha over 2 will be equal to 1.96. Again, I'm going to pop this on a spreadsheet just like I always do. So, because of this formula up here, I have n equals 1964, which is my population standard deviation, times 1.96, which is my z sub alpha over 2. Multiply those together, divide by 750, get some number, and then square that. Well, that gives me approximately 26.34. But remember, this is n, and n has to be a positive integer. So this is saying that 26.34, 26 would not be enough teacher salaries to survey, but 27 would be. So we round up to 27, and that would be our answer. Let's go to spreadsheet mode. Okay, so here I have a spreadsheet all set up for us. We have E. Remember, that was 750. If you don't believe me, go back to the problem and check it out. Sigma or S, we were given that as 1,964. My level of confidence. Level of confidence was not given in the problem, so we default to 0.95. Alpha equals 1 minus my level of confidence. Alpha over 2 we actually need. We just say equals whatever we got for alpha divided by 2. And now z sub alpha over 2, remember the z function actually sometimes gives me the negative value. One thing to note is that when we go to the next part of this unit, the third video for this unit, we're going to do something called hypothesis testing, and we actually are sometimes going to use a negative value for z sub alpha, sometimes the positive value, and sometimes, well, basically both values. For confidence intervals, we always just use the positive one, which means I'm going to nest the norm.s.inv inside of an absolute value equals absolute value of norm.s.inv of alpha over 2. I close the norm.s.inv parenthesis, and remember that whole thing about it being red, so I'm just closing that one. And now I'm closing the absolute value one, and I am pressing enter. To calculate n, remember, I would have to multiply S or sigma times z sub alpha over 2, divide that by E, and then square that result. So equals, open parenthesis, my S or sigma times my z sub alpha over 2 divided by E, close parenthesis, and remember to get squared, I use the caret or shift 6, which means raised to the power of 2, and I get 26.34-ish, but that means that the minimum sample size will equal, round up, open parenthesis, going to grab that n is greater than thing, comma, number of digits is 0, close parenthesis, and press enter, and there we have 27. And that is the answer. If you have to do one by the range rule of thumb, it's going to be the same thing. We're just going to have a maximum data value and minimum data value, and over here we would subtract the min from the max, get that result, divide that result by 4, and then we would just use whatever we get over here for my S or sigma in the function over here, or the formula over here. That's all for this video.